Come on, everybody now, gather round faster. Stone's about to talk about his modified blaster.
Alright, so in this video I'm going to go over sort of my progress, a progress report, if you will, for my Nerf Turret 2.0. When I did the first turret, it was for school. I was in a big time crunch, so I just had to whip it out as fast as possible. But for this one, I'm taking my time. You know, I got a lot of time to do it, so I kind of wanted to go over some steps. So this is the first of a few videos where I'm just going to talk about my Nerf Turret 2.0 in more detail. Without further ado, let's go. Alright, with my second iteration of this turret, I made some changes to the base. This was shortened significantly, and one of the things I realized is that all this spaghetti going through my slip ring. So in this iteration, I want to have everything on board, so the base portion that will be attached to the surface is a lot shorter. I will probably just end up drilling a hole, but for now, I just have the slip ring for power, and that is the only portion of this that will need to be spinning. All of the other electronics and wiring will be within their frame of reference, they'll be stationary. So that was the first major design change that I made. I am still using this 8-inch Lazy Susan style, I guess, slew ring or bearing, because it works wonderfully, and I can get it off Amazon. I think it's about 20 bucks. But I loved working with it here, and so I'm just going to probably continue using these. If I make a bigger one, I'll probably just buy the 12-inch version of this. And then before we get that attached, I want to talk about the upgraded gear. So we've got this inner tooth gear is stationary here, and then within that we've got I guess a pinion. So the pinion will walk the turret around the stationary gear, and this is a much better design than what I had before. It's using the fishbone teeth instead of just standard spur gear, and it's a 5-to-1 ratio, so more than enough for the stepper to handle. I have a sort of a ridge here so that as the gear is rotating around, there's no friction against the next surface. Alright, so as you may have noted, I only have 3 M4 bolts in here with the Phillips head, and that is because I didn't measure. When I modeled this thing, I didn't do it absolutely perfectly, and instead of messing around with it a bunch, I just settled for 3 points of contact, which I think for this application is going to work out perfectly fine. The next portion is sort of the power housing. In the past I was using larger switching DC to DC switching converters, but for this I found some cheap small ones, and so I think for at least the microcontroller power and hopefully the power to the DC motors, these will be enough. I can just have a few of these, maybe with some standoffs placed in these little areas here. So this also has the housing. Before I had the stepper mounted to the base and then it was turning the platform around, but because I wanted to have everything electronic other than the power going into this to be contained within, I had to do a different method. So the stepper fits up here now. So to gain access to the gear and the stepper, I just have this little window, and this is also how the gear reaches the slew ring. And then I just have a tiny little set screw that pins the gear to the flat portion of the stepper shaft. So we've got the base attached, we've got the gear system in place. I've just hooked up a quick little Arduino code along with a stepper driver just to kind of demonstrate the difference in sound. There's a massive difference in the noise this creates now. I actually think it's kind of a nice little sing-song sort of stepper noise now instead of a horrible grating. So we're going up the next level here. And this will be the final portion that I go over in this video, because that's where I'm at in the project. But it is this portion here, so it fits over, covering the stepper motor, and this essentially, this entire portion is just what is going to house my stepper drivers. And these are way overboard for what I need, but they were pretty cheap compared to the previous drivers that I used. They are limited in some of their capabilities because the micro stepping is actually set by switches, whereas the stepper drivers I used before, I could change the micro stepping within code. With the way this is geared, I think it'll be just fine as far as speed, acquisition of target, and all that. So let's get this attached. Okay, so I've got this little port, I guess, here that I'm kind of running all the wires through. My next step is going to be to design a platform that seats into here, and then eventually we'll be holding the pitch arms, I guess. That's kind of my next step in this project, is to get this platform and new arms here created. But as far as having a nice little rotating base for, I guess, any other designs, I'm pretty happy with how this has turned out, and I don't see any vast improvements that I'm gonna be making to at least the rotational base in the future. Definitely be using this for multiple turrets going forward. Thank you all for watching, and remember, you can be serious about Nerf, but don't take Nerf too seriously.